Alright, so we're taking a look at a couple of examples from section 4.3, actually the exercises. And so this is exercise 1, and we're given this graph of f of x, and we're told that the area of the red section is 18, the area of the black section is 6. And so now we want to compute some quantities. And so the integral from a to b of f of x dx, that's going to be the area from a to b is going to be this area here, but because we're below the x-axis, it's not going to be positive 18, it's going to be negative 18, right? So we would say negative 18 is that area. So that negative sign is important here. What's the area, or what's the definite integral from b to c? That's going to be 6. And then the integral from a to c is going to be the minus 18 plus 6, because we're adding these two together in terms of signed areas. So this is negative 18 plus 6, so that's minus 12, right? And then the last one is kind of interesting. We're taking the integral from a to c of the absolute value of f of x. And so rather than having a negative 18 here, when you take the absolute value of this function, it actually pops it up here, right? So that the area then becomes a positive 18. And so this is going to be positive 18 plus positive 6. Good. Let's see, what is that, 24? Okay. We'll go on to the next one. Alright, so this is exercise 3, I guess. We're going to find the average value of the function 7x plus 1 on the interval from 3 to 8. Okay, and so I'm going to need to compute the integral from 3 to 8 f of x dx, and then divide that by 8 minus 3. Okay, so that's the quantity I'm looking to compute. Let's see, that's going to be 1/5 of the integral from 3 to 8 f of x dx. Good. So how are we going to compute this integral from 3 to 8 f of x dx? Well, I've already drawn a picture that we can use. You can take the area of the big triangle minus the area of the small triangle. Okay, so the area of the big triangle, will be, let's see, this is 8 units and then plus 1/7. How did I get the 1/7? I looked for where 7x plus 1 was equal to 0, and I solved for x. Okay, and then if I plug in 8 here, I'm going to get a big number. That's not to scale, so it looks like 57. And then the area of the small triangle is going to be 3 plus 1/7 times the height. The height is, I'm plugging 3 into this, 21 plus it's 22. Oops, times 22. Good. So then you can just take these areas and subtract them. Good. I'll pause and compute that real quick. Okay. Sorry about switching the graph on you. So we're trying to find the average value of this function 7x plus 1 on the interval from 3 to 8. And it's pretty straightforward. You take the area of the big triangle minus this area of the small triangle. And so the area of the big triangle is going to be 8 units from here to here, from the origin out to 8, right? And then there's another 1/7 units there, so it's going to be 8 plus a 7th for that whole thing. That's the base. Then the height is found by taking the height at 8, so plug that in and we get 57. And so it's 1/2 base times height. You should get about 232.07. Now the area of the small triangle is again 1/2 base times height, so it's 1/2, 3 plus a 7th, and then you multiply by 22, which is plugging 3 into your formula. So that's about 34.57. So if you subtract these two numbers, you get that the area right here is about 197.5. Okay, So what is the average value going to be? Well, it's going to be 1/5 of that value, right? Um, so now we just plug in our numbers. 1/5 times the integral from 3 to 8. By the way, that 5 came from taking 8 minus 3, right? F of x dx, and that turns out to be 39.5. Good. So that is number 3.